want to introduce to you this idea called a reference angle. And a reference angle is a great way to help us to look at our problems in a little bit more of an easier scope. So what a reference angle basically is that I have some angle. And so let's look at the example that I'm going to look at. I have a 345 degree angle that I'm exploring. And so 345 degrees is probably in about that direction or so. Well, its reference angle is not 345, rather its reference angle is what's the angle to its closest x-axis, which would make it, what's that particular angle right there. And so if I know that the entire scope was 360, and 360 minus 345, its reference angle would be 15 degrees. So reference angles are always the angle that we create with the x-axis. So let's do a couple other examples of what that could look like. All right, let's look at the theta at an angle that equals 5/6 pi. I know I was in degrees last time. We're going to go to radians this time. So what quadrant is 5/6 pi in? Well, 5/6 pi is probably in that general direction. We remember that 180 degrees all the way over to the x-axis again, or that's also 1 pi. And 5/6 is less than a pi. So we're going to be wanting to know what that particular angle is. So this angle right here, we know that to be 5/6. That's what theta is. This one over here, and sometimes you might see it called theta 2, or theta prime, sorry. So what's theta prime? What's the angle to the x-axis? And so if we know the entire distance is pi, and theta is 5/6 pi, theta prime has to equal 1/6 pi. All right, another example. How about theta equals a negative 135 degrees? All right, so theta equals a negative 135 degrees. I'm hoping, I'm looking at you guys right now, and you guys are thinking, all right, he's going to ask me, which quadrant is it in? Yep, you're right. So which quadrant is it in? Where does that line up at? 135 degrees. I know that it's negative, so it's coming around this direction. That's 90. This is 180. I think 135 is right in the middle. So it looks like that theta right there is negative 135. So it would be this distance right here, or that angle, that we're going to call theta prime. So what is its measurement? Well, 180 degrees, take away this chunk of the pi, will give me 45. And that, oh, and a good example where I'm doing this one too. We always want the positive angle value. So even though it looks like it would have to be a negative 45, we want the positive value. So in this case, it's reflective. Its reference angle is 45 degrees. Yep, 45 degrees. All right, next one. Got two more for you. What? 2.5? What in the world does that mean? Oh yeah, theta equals 2.5 radians. When it's not labeled, it's radians, and 2.5 radians is what we're looking at. And so kind of have to put my thinking cap a little bit to kind of think about where does that land in it. And So if I travel all the way over to the x-axis, that's traveling pi radians, and pi, if we cranked out the number, would be roughly 3.14. So I have some angle that's marching up in that direction. My theta right there is 2.5. So I'm wanting to know my theta prime. So I would have to translate pi into roughly 3.14. Subtract out theta, which is 2.5. And so my theta prime would be whatever that leftover stuff is. What do we get? We got 0.64. So theta prime is 0.64 degrees. Oh, nope, nope, nope. 0.64 radian. All right, last example. $580 degrees. What do we do with that? Well, we got to brush back to a couple of the pages in the textbook a little bit. Remember last section, we talked about coterminal angles. And one thing that we're going to do is we realize that 580, that's a whole rotation around the circle plus some. So let's remove at least one rotation if we need to. Maybe sometimes you need to remove 3 or 4 or 5 rotations. But if this is in degrees, we know a full circle is 360 degrees. So we don't have quite enough for 2 rotations around it. So let's subtract out 360 degrees. And that leaves us with 220 degrees. Do you guys agree? It's not uncommon. I make mistakes sometimes shooting videos. So if I make a mistake, you just yell your hand up there and I'll fix it. So 220 degrees. Is that its reference angle? Nope, not its reference angle. 220 degrees. Up is 90. This way is 180. 270 down. So 180 to 270. So my theta, or my coterminal theta, let's say it that way. My coterminal theta is 220 degrees. My theta prime, which is just this little batch right there, theta prime, what's the remainder? I'm going to have to subtract 180 degrees from that. Equals 40 degrees. So my reference angle there is 40 degrees. Now, I hope you're starting to see how this can possibly be useful as we can kind of solve some other problems in a little bit more of a quicker way. So keep playing along. We're going to get there, guys.